So, welcome to a terrific Math Thursday. I'm going to go through the different Delta Math topics for today and give you a review of what some of the skills are. Some of them are new, but for the most part, they're skills that you already have, and this is practice. So, our first topic is applying the Pythagorean Theorem to find the lengths of missing sides. If this is 18 and that's 24, I happen to know that this missing side is 30, but I'll prove it to you with the Pythagorean Theorem. So here we go. What you're going to do is always copy down the formula first. A squared, come on, plus b squared equals c squared. And then once we've got that, we're going to be able to sub in our unknowns. 18 and 24 are both legs, meaning that they are the shorter sides of the triangle, so they belong with A and B. So with 18 squared plus 24 squared, well, we'll have our missing side c squared. Come on. Now, 18 squared, what is that? You can just use a calculator, of course, and find that that's 324. And then 24 squared would be 4 times 144, but I'm not going to do that in my head. 24 squared gives me 576. And that equals c squared. Well, that happens to be 900 equals c squared. And then that gives us a road to our answer. Here, we know that the sum number squared will equal 900. So if I take the square root of both sides, it will tell me 30 is equal to c. And that's the desired answer there. Now, how did I know this was 30? Well, first they find the hypotenuse, and yeah, c is the hypotenuse. And they just go ahead and do it that way. But the way I was able to do that in my head very quickly was, and I'll show you here based on this triangle, 18, 24, 30. There we go. Let's say we have that triangle here, and I compare it to this triangle, which is the same thing. 3 times 6, 4 times 6, and then this would have to be 5 times 6, because it's just a variation of the 3, 4, 5 triangle. And that's how you're able to do this very easily. And if you memorize some Fibonacci triples, these questions will be very fast. Okay, let's do one more example. Let's try and get one where the, okay, so here at 9, 5, so if necessary, round to the nearest tenth. So we have 25 plus 81, and that would give us 106, so 106. And take the square root of that is 10.3. 10.3. Okay, so how did I do that? 9 squared plus 5 squared should give me the length of the unknown side squared. So I did 81 plus 25, which gives me 106. And then I take the square root of that, which is 10.29563, blah, blah. And then what am I asked to do? Round to the nearest tenth. So if I'm rounding to the nearest tenth, I have to round correctly, or Delta Math will say I'm wrong. This would be the 10th, and the nearest 10th would be 10.3. It's closer than 10.2. So I submit that answer. Yes. Huh? Submit. Yes. I want to accept it. Huh? Well, that's strange, isn't it? What's happening? Huh. Let me figure that out. Don't know what was happening there, but it was the correct answer. Okay, so now we're being asked to find the length of this side. So it can help to copy down the triangle for sure. Just do your best diagram. Call the unknown side some letter. X is a classic. And then 5 and 13. Copy down your formula. A squared plus b squared equals c squared. And then you're going to go ahead and sub in. 13 is the longest side. It's opposite the right angle, so it has to go in for c. So I would say this is equal to 13 squared. And then 5 and x are your shorter sides, so let's say x squared plus 5 squared should equal 13 squared. And if you've memorized your Fibonacci triples, you'll recognize that that unknown side is 12. But if you haven't, you plug and chug, and you'll get there too. So this is x squared plus 25 equals 169. Now, I'm going to go ahead and subtract 25 from there and there to move it to the other side of the equation. That is going to help me isolate x. So I have x squared now is equal to 169 minus 25, which I happen to know is 144. The calculator would tell you the same thing. And now I know that some number squared is 144, so I take the square root of both sides. And that will give me x is equal to 12. Let's input that. Oh, here we go. Oh, enter. And now it's working. Okay, so that's how you complete those. Area puzzles. These are fun. Okay, so we're told here that all of these are squares, and we want to find the area of the shaded region. Okay, what area is shaded there? Oh, that's kind of interesting. So how are we going to approach a question like this? Let's see. So what I would do is make a diagram and then figure out some of my unknowns. All right, so there's a larger square over here, which happens to be 15 on a side. And then these smaller squares here are 10 on a side. So that means that this whole side is 25, because I was told that all of these are squares. And this one up here, well, if this whole thing is a square, all of the quadrilaterals are squares, so the big one is a square as well. And that would mean that this is over here 10, and this is 25. So that piece of information that everything is a square, that really helps. And so if that's a square, then this is a square here. It's also 10 by 10. This was a 15 by 15 square, and I want to know how much is overlapping, because I can remove that overlap from the square 15 by 15 to find the area of this. Well, the overlap here, this would be 5 by 5 this way. So the area of this overlap here would be 5 times 5, or 25. The area of this before I removed the overlap would have been 15 times 15, 15 squared, because I'm told it's a square, and that's 225. So 225 minus 25 will give me 200. Hey. Yeah. So now let's go ahead and take a look at another one. Okay, so a rectangle is framed within another. So if the frame is 2 units wide, what's the area of the frame? What's the area of the shaded region? Okay, so there's a few ways to approach this problem. I could divide that frame up into 4 rectangles and calculate the area of each rectangle. And doing that quickly in my head, I have 1836. The answer here is 36 plus 28, which is 64. 64, I believe. But let's take a look at another way to do this problem. Okay, so here, what I'm going to have is, copying out my diagram, smaller rectangle in the middle. This is 7 by 5. And if the frame is 2 inches wide, it's going around 2 inches around the outside. And that would mean this is 11 long. Why is that big rectangle there 11 long? Because this is 2 and this is 2. So I need 7 plus 4, which is 11 there. And then how long is it on this side, the other side? Well, it'd be 5 plus 4, which is 9. Okay. So the area of the big rectangle is 9 times 11. That's the outer rectangle. And if I subtract the inner rectangle, then that will give me the shaded area, which would be 7 times 5. So 9 times 11 is 99 minus 35. That will give me 64. Okay. I could have, what I did before when I did this one just a second ago was instead I divided it up into 4 rectangles. So I did this, and I knew this rectangle was 2 by 9, and then I went, that rectangle was the same, 2 by 9, so I just multiplied 18 by 2 to get 36, and then these rectangles are 2 by 7, so each one was 14, so 20, so 28, 36 plus 28, so different roads to a solution here. That's kind of interesting. That one is 64. Hooray, let's do a couple of those. Maybe I'll have you do more because they're fun. Next, we have to do Pythagorean Theorem a few times to solve these ones. Okay, so solve for x and leave your answer in simplest radical form. So looking here, my first step that I need to notice is that this 4 will be the same, like that will be the base of the triangle. So what I will set up is a Pythagorean theorem where I have 4 squared plus 11 squared equals x squared. X is the hypotenuse, so it's the longest side, and that's a triangle 4 by 11. That side length 3, it's not relevant to the problem. I don't need it. So there you go. This is 16 plus 121 equals x squared. X squared is then 137 will be equal to x squared. And then taking the square root of that, I predict 11.8. Let's see. Maybe 11.7. Okay. 137. Oops, clear. 137. Take the square root of it. 11.7. What did I say? 11.8? And I revised my guess to 11.7? I can't remember, but I'm kind of pleased. Okay. Oh, give your answer in simplest radicalist form. Simplest radical form. Okay. So here, right, I forgot to mention, there are problem types here that ask for things in simplest radical form. I better teach you about how to do that, eh? But I also changed the penalty to none. So if you want to skip these, you can. And some of the other question types are give us a rounded answer. Okay, so here, if I know that, where's my whiteboard? Here it is, that 137 is the number that I'm looking for, then I can just write in the square root of 137, and that should work. The answer is not correct. Okay, so, okay, I wasn't reading the diagram correctly, was I? All right, so let's take a look at another one. Here we go. These ones are ask you to round to the nearest tenth. So for these types of questions, we can absolutely solve it. But we notice here that there's 2 triangles nested in this diagram, and we want to be able to find x, we first need to find the hypotenuse of that triangle. So, and we're asked to round to the nearest tenth, so that should be fine. If I copy the diagram, it can absolutely help. So I know this is 7, this is a right angle, this is 10, and then I have another right angle triangle coming off here. This is 3, this is x, and then I don't know this side, so let's call it y. I know that a squared plus b squared equals c squared. So I can put in 7 squared plus y squared equals 10 squared. Oops, 10 to the 0? No, 10 to the 2. Okay, so I know this is going to be true because that's my first triangle. So let's go ahead and solve that one. 49 plus y squared equals 100. Y squared equals 51. So y equals the square root of 51. Square root of 51 is going to be 7.1, if that. There. 51, but I take the square root. 7.14. Oh, it's actually solidly 7.1. Okay, so y squared is 7.1. Y is 7.1. But one neat thing here is that I don't actually need y, I just need y squared, okay? Because over here on this side, when I figure out this triangle, I'm going to have 3 squared plus x squared equals y squared. I know y is 7.14, blah, 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 but y squared was exactly 51. So let's just use exactly 51 over there. Instead of subbing in for y and squaring it, let's sub in the exact value, 51 for y squared. 3 squared was 9, and x squared is just x squared plus x squared. Subtracting 9 from both sides gives me x squared is equal to 42. And then I take the square root of both sides, and that would be x is the square root of 42. And so let's find that out. 42, but I take the square root is 6.5, rounding to the nearest tenth. Notice that 6.48 rounds up to 6.5. So I put that in, 6.5. Cool. If I push submit, I will not go because my internet is down. Okay, carrying on. The final reveal. Let's see. Hooray! So let's look at one more example. Find the value of x to the nearest tenth. If I put in a wrong answer in this section, it should just advance me to the next question with no penalty. So why did I do that? Because there's a question type here that we wouldn't expect you to answer until grade 11. And that's this type of question. Solve for x and leave your answer in simplest radical form. And I'll talk you through and I'll show you how to do it. So that way you're nice and ready for grade 11. And this is also really good for your number sense and understanding what is meant by a radical or what is meant by a square root. So here, I'm going to start with my diagram. And so I know that I have here a triangle. Oh, and I can do this, make beautiful triangles. Here we go. Boop, boop, boop. This is triangle number 1, and this is 7, and this is 6, and this we don't know it, call it y. And then the next triangle comes up here. This is the right angle, comes down here, and that's 6. No. And then this is x. Okay, so in order to show this in simplest radical form, what I'm going to do is find out y, but I'm not going to use the decimal approximation. I'm going to find out actually y squared. All right, so what I'm going to have is a squared plus b squared equals c squared. And then I'm going to sub in my values. 6 squared plus 7 squared equals y squared. Okay, so that would be 36 plus 49 equals y squared. Y squared will then be 55. So 85. I was thinking 85 and saying 55 because 55 happens to be one of my favorite numbers. And that's y squared. Y is the square root of 85, but I don't care. Okay, I'm just going to leave it as 85. Why would I do that? Well, I'll show you. Next, I'm going to have a squared plus b squared equals c squared. Now working in this triangle here. Okay, and so now we notice that 6 is still one of the shorter sides, but the other one is still y. Y squared is equal to x squared. Okay, and now let's substitute in the things we know. We know that 6 squared is 36. We know that y squared is 85. So put in for y squared. Notice I'm not squaring 85 because 85 is y squared. So I put that in for y squared. And then that's going to equal x squared. Now let's do the math. 36 plus 85, is that 121? Is it really? That would be pretty cool. 36 plus 85 is 121. I'm just a little bit in disbelief. 36 plus 85 equals 121. Well, that's boring. It's not a very good example. Anyway, and here I take the square root of both sides to find that x is 11. and I input that, and then we go for it. Oh, it's a little sad. That's the simplest radical form, is just 11. Let's do another one. Solve for x to the nearest tenth. I don't want to. I want to do another one where I get to show you simplest radical form. There we go. All right. So if that side is 14, this is 5, 4. Good. This one will do. This one will be a good example. Okay. So with these types of diagrams, first start by copying the diagram. So here we go. I'm going to have one side that is 14, one side with a right angle there, 5, one side shorter than 14, 10, and then one side unknown here, x. This is a great example. Now when I do this to create a triangle so that I can solve for x, I'll know that side is 5, but this side from here to here is 14 minus 10, which is 4. Okay, and I know that there's a right angle there. So now we can do x squared plus y, a squared plus b squared equals c squared. 4 squared plus 5 squared equals x squared. All right, and now we got 16 plus 25, which is still x squared. 16 plus 25 happens to be 41 equals x squared. So in this case, the square root of 41 is x, and they want the answer in the simplest radical form, so put it in that way. 41 is prime. That is already simplest radical form. If you're interested in why is it not accepting an answer like the square root of 80, let's say you had the square root of 80 here. This is not simplest radical form because the square root of 80 could be written as the square root of 16 times 5. 16 is a perfect square. This can be written as the square root of 16 multiplied by the square root of 5. We can write these in this way, and that's how radicals work. You can break them apart like that. And then the square root of 16 is 4, and the square root of 5 is 5. So the square root of 80 is the same thing as the square root of 4, of 4 times the square root of 5, and those are exactly the same. So that's what we mean by reducing a radical. All right, now let's go to some more problem types. So we've done multi-step Pythagorean theorem. Now let's take a look at area of triangles very quickly. So if we want to find the area in square meters of this shape below, and we want to write this as a fraction in simplest form, it's a 3/4 meters by 4/5 meters. So for this, I'm going to use the area of a triangle formula, which is base times height over 2. And that's equal to, well, the base here is 4 over 5 multiplied by 3 over 4. And then I'm going to divide the result of this by 2. Okay. I also make sure to note that here there's a right angle joining these two sides. If I don't have a right angle between the sides, I can't use them for area. Okay, so 4/5 times 3/4 over 2. Okay, so now 4/5 times 3/4 happens to be 3/5 divided by 2. How is that 3/5? Because the 4 cancels the 4, and I'm only left with 3 over 5. And then 3/5 over 2 is the same thing as 3 over 5 times 1/2, which is equal to 3 over 10. 3 over 10 is already is a fraction in simplest form, so I can put that in as a number of meters squared. 3/10 meters squared. So my answer. Let's do another one. Okay. What's the area in square centimeters of this shape? All right. Well, it's the same because it's the same measurements. So when I recognize, oh wait, no, it's not. It's 3/5 over 4/5. So then I have 3/5 times 4/5, which will give me 12 25ths, but it's half of that. So it would be 6 25ths. 6 25ths is the correct answer here. Okay, so why? Well, and you should practice doing these in your head too if they're easy for you. 3/5, this is base, this is height times base divided by 2, which is equal to 12 over 25 divided by 2. So here I can just divide 12 by 2, which is 6, and that's 6/25. You want to be able to do those 6 over 25. Good review of our fractions. Next, composite shapes, triangles and trapezoids. Okay, so we want to know the shaded part of this rectangle. It's a rectangle that's 9 by 11. And so there's two roads to a solution here. I could find the area of the big rectangle and subtract the triangle, or I could use my trapezoid formula to do that. So I'm going to do the first method because it's a more thinking method and I like that. So the area of the big rectangle is base times height. The height is 19, the base is 11. And then I'm going to subtract the area of the triangle. So here it can help to have a diagram, of course. Copy the diagram. So here's the top side, here's the downside, the 19-inch side. There's a triangle that I'm cutting out there. Okay, and I'm interested in this area. No. Okay, so here, this is 19, this is 10, so this one must be 9, and this was 11. So the area of the triangle would be, and so I'm going to subtract the area of the triangle here, 9 times 11 divided by 2. Okay, so 19 times 11 happens to be 209. Yeah, 209 minus 99 over 2. Okay, so 209 minus 99 over 2. And how do they want the answer? I think they'll take a decimal answer. So I'm going to just approximate with decimals. 99 over 2 happens to be 49.5. So 209 minus 49.5. Well, that would be 109, 159.5. I believe. 159.5. Let's see if my mental math without checking is any good. 159.5. Spoiler alert, it might be wrong. No, it was right. Okay, good. So that's how you could approach that one. Sure thing. Next. So next we're going to look at some nets. So what is a net? A net is kind of like if you have a box and then you unfold all the sides of the box and lay it out, that would be a net. A net is a two-dimensional shape that can be refolded into a three-dimensional shape. And these are really useful when we start thinking about three-dimensional shapes because we can use them as models to find the three-dimensional shape surface area. Area is always two-dimensional. A three-dimensional shape will have a two-dimensional surface area, not a volume. All right, so here is a gift box that is in the shape of a triangular prism. This is the net for the triangular prism. And how much wrapping paper did he use means find the area of this shape. How many am I asking you to do? 2. Okay, that's why. So here I have composite shapes. And what I'm going to do is, rather than copy out the diagram, I'm just going to work beside it and find the area of all the shapes. I could do a big rectangle down the middle. Actually, I am going to copy down the diagram. And I can do this in 3 shapes, actually. A big rectangle down the middle, and then 2 triangles that are identical. So how long is the big one down the middle? Well, it's 6 here, 5 here, and 7.81 there. So add these all together is 18.81 is the length from here all the way up to here. Okay, that's 18.81. That's a rectangle, and that is also 7 wide. So the area of that rectangle is equal to 18.81 times 7. Don't do that in your head. Do that on a calculator. 18.81 1 times 7 happens to be, make a guess first. I'm going to guess that it's about 130, 131.67. Okay, equals 131.67. Always make that little guess before you push equals on your calculator because it really does train your thinking about these things. And next are these triangles. The triangles are 6 by 5. There are 2 of them, so combined area 30. I know because 6 times 5 is 30. If I divided it by 2 and then multiplied by 2 because there's 2 of them, I'd get 30 back. Okay, I'd get 15 times 2. All right, so the total area is going to be 161.67. Cool. Let's type that in, 161.67. Notice that they're giving me the unit here already. That was kind of them. Hooray! Okay, so those aren't that bad. Practice, try some. Surface areas from nets. Next, perimeter. So here, we're asked to find this length of this unknown side, and we're told the total perimeter. Okay, so here, you're going to use what you know about perimeter to find an unknown side. You would set up something like this, and this could be, again, a net for some kind of triangular prism. It looks like the 5.7 sides match up and create a triangular prism. And this is sort of like saying, what's the edge length of that three-dimensional figure? But then we'd be missing the 2 folds, so I'm not sure about that. So here, this is what we've got. The total perimeter will be equal to all the sides added up. And what are all the sides added up? Well, there's 8.9. 0.9 is one of the sides, but it happens twice. Okay, 8.9 times 2 plus 5.7 is another side, but it happens 1, 2, 3, 4 times. And then we also add a 10.6, and we're also going to add, forgive me for working vertically there a little bit, 2.6 times 2. There's 2.6 sides. So I can use multiplication to speed that up a little bit. And then I'm going to just crunch that on a calculator. So there we're going to have a calculator. 8.9. Oh, and I should also say plus the unknown side. So plus x. Okay. Because that's this unknown side there. So now let's get our numbers, get our calculator. 8.9 times 2 plus 5.7 times 4. Fast use multiplication there. Plus 10.6 plus 2.6 times 2 equals 56.4. So I know that the perimeter is equal to 56.4 plus x. Okay. I know it's 56 plus 4 plus x, but I'm also told that the total perimeter is 66.6. So let's put that in. 66.6 is equal to 56.4 plus x. And so here x must be 10.2 if I subtract 56.4 from both sides. So this is 10.2. And it likes that. So notice it's not exactly the same thing as that. It's different. And they did that to trick us. So don't just assume. You have to check. Okay. And next would be some algebraic ones. These ones we need to use, we're going to get to review some of our algebra ideas. So we want an expression that represents the perimeter below in simplified form. So count them up. How many D's? I see 2 D's. So let's put in 2 D's. Where are they? There's one, and there's one. I'm just going to zoom out so we can see it and put in our answer. And then there's how many D's? 1, 2, 3, 4, 5, 6 G's. So it's plus 6G. Oops, what's happening? 2D plus 6G. And then how many F's? 2 F's plus 2F plus, and then how many E's? 1, 2. 2e. Oh, there we go, 2e. And then you say submit answer, and that will give us the perimeter, that expression that we just created. Okay, so they color code here for you. Use their visualizations. It's very helpful to have some good visualizations of these topics. Now, volume of rectangular prisms. Okay, so these are visual kind of training you problems to think about these things. So answer all the questions below. So we're going to do that. We're going to say play. Boop, boop, boop. How many cubes are currently in the prism? There are 4. I see it's 4 tall. So if this prism is 4 tall, there's 4 along there. So try that. Yeah, and then press play. Now, boop, 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 boop. Now how many cubes are currently in the prism? Well, I see it's 4 by 10 cubes. So 4 times 10 is 40. So I'm going to try 40 here. So try. And it likes that. Okay, and then I'm going to say play. And then boop, 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 boop. Oh, there's 6 40s in there. So 6 times 40 is 240. And then I'm going to say try. Volume of the rectangular prism is 240. Submit the answer. Enter. Hooray! So these are just to get you practicing and visualizing those columns of sugar cubes that would fill up that shape. Now, let's look at volume of rectangular prisms down here. If we know that this rectangular prism, which is like, imagine a bar of gold, it's not trapezoidal, it's just like a brick, okay, and it's 15 inches, 9 inches high, and 7 inches wide. What's its volume in cubic inches? Well, all you do is you multiply length times width times height. You multiply the 3 dimensions to find volume, and so that will give me 63 times 15, which will be 630 plus, so it's 945. 945 is 15 times 9 times 7. There. So that's how you do those. Okay, let's do some more. It's the volume of cube in cubic meters of a cube with an edge length of 11 meters. So if you're confused, draw a diagram. And here, I have a cube. So all the sides are the same. Here is one edge, another edge, another edge, and another edge. And then we draw a third dimension, giving the impression of depth here. I have to change those. I don't think I've ever used sticky keys in all my life. Okay, so anyway, all of these are 11. 11, 11, 11. So the volume is going to be equal to 11 cubed. 11 cubed. So that's 121 times 11. 121 times 11 is 1,331. 1,331. Hooray! So if you were not able to do that in your head, you can do this, but make a prediction. You might say, I think this is going to be a little bigger than 1,000 because 10 squared is 1,000. And then you use your raise to the power Y button, and I'm going to push 3, and then I push enter, and then it says, oh yeah, it is a bit bigger than 1,000. It's 1,331. There we go. So that's how these are done. So I hope that your math practice with these topics is fruitful today. Any questions, absolutely hit me up by email. And have a terrific Thursday, everyone.